So here we go again. This talk is entitled Einstein says 1 equals 0. So source of my information is a talk given by Stephen Bryant, and he explains that Einstein says 1 equals 0, and this is a clip from his full talk at this web address. So Stephen Bryant has been looking for some simple way of explaining to everybody that Einstein doesn't make sense. Something a lot of people have been trying to do over the past 100 years is to explain to people that Einstein really doesn't make sense. So here's the talk, let's go.
Which is Einstein says 1 equals 0. And it's actually fairly easy to develop a proof that shows that 1 equals 0 is a false statement. So when we look at this, we can say, well, where does Einstein say 1 equals 0? I've looked at his paper, I don't see it anywhere. And what we have to do is we have to first explain the idea of an abstract case and a concrete case. Now, before I go too far, we are going to look at math, but I really want you to look at what they look like, not so much worry about the Greek characters. We have 2 Greek characters on this page. We have psi and we have tau. Psi looks like the cursive E, and tau is next to the C symbol, and it looks like, I don't know, maybe an R. So xi and tau, they're just Greek letters. And if you're not comfortable with Greek letters yet, I know many people watching today are, just think of them as 2 extra letters that we've tacked on to the end of the alphabet. So A, B, C, D, E, F, G, go to Z, and then add these 2 letters. So nothing magical about them. What we're showing here is Einstein's derivation from section 3 of his 1905 paper. And what I want to come to is this point that is number 1. Because this is a very important statement. This is where Einstein actually creates psi. It's a statement of creation. And in mathematics, when we have a statement of creation and it's a statement of equality, which is what this is, this relationship must always be maintained. It's not only true on Mondays, it's not only true sometimes, it's not only true when it's convenient for us. It is always true. So we can test this. I'm saying Einstein says 1 equals 0. We can put this to the test. However, there's a problem with our putting this immediately to the test, which is we don't get to directly specify psi or tau. Those aren't one of the variables that we get to state. But there are some variables that we do get to state. And Einstein tells us what they are. And they are x, y, and z, and velocity v, and time t. So we can use any combination of those variables and give them concrete values. We don't need y and z for our conversation today. So you can see over here, we're just going to look at x, v, and t. So this leads us to a question. Is there some way for us to use x, v, and t and put them into some equations and put this to the test? And the answer is yes, because Einstein gives us the transformation equations that convert our x's, our v's, and our t's into tau and xi. Okay, so we have what we need to go from an abstract case to a concrete case, which we'll do here, and we'll work our way backwards. So we're going to start by trying to solve for xi, which we'll do over here. And we have some terms. We're going to use x equals 1, v equals 0, t equals 0. I've picked those values because they're easy and we don't need a calculator to see what's going on. So we just do simple substitution from algebra. X becomes 1, v becomes 0, t becomes 0. We solve this equation, we get 1 minus 0. There is a beta term here, but from Einstein's equations, we can see we have this equation. He tells us what beta is. We've set v to be 0, so this becomes 1 over the square root of 1, which is simply 1. So beta is 1, so we can basically ignore that for the rest of our conversation today. So we get psi equals 1 on this side. How about on the other side? Again, Einstein tells us what this equation is. We come over here, we say t equals 0, v equals 0. Well, anything times 0 is going to be 0, so this becomes 0. So we get 0 minus 0, beta doesn't matter, we get tau equals 0. You feed those into the equation, we have 1 equals 0. So it's a fairly easy proof to show by using a concrete example. In this particular case, I've picked variables where it will be the case that 1 equals 0. And again, that should not happen because if we know the statement of creation, this statement should always be true. And we found a case where it is not. But that takes us very quickly to the first insight that I wanted to share with you. And we have 10 of them, so I'm glad we got to the first one rather quickly. And that is, Einstein says 1 equals 0, which is mathematically incorrect and invalidates relativity theory. That's the key message. If someone wants to say, okay, I've got the key message from today, this will be the key message. But I'm hoping that now you want to stick around a little bit more because this should raise a number of questions.
Okay, so I think if you go over what Stephen says again, it might make things clearer. And here's the usual translation we refer to for the 1905 paper from Einstein. It's untitled On the Electrodynamics of Moving Bodies by Einstein, June 30th, 1905. And it's at that web address there. And I usually complain in other talks that it was not properly translated, but now I just want to put that issue aside and just look at the maths that is presented in that paper. So this is the maths. It's got Greek letters, and not everybody likes Greek letters. And so since tau, and that's a Greek letter, is the linear function, it follows from these equations that you get this equation that tau equals to a all times t minus v over c squared minus v squared, and then that's times x prime. So a is a function which is using another Greek letter, phi, so that's a function of v, and it's at this point in the derivation it's unknown. So he carries on using his Greek letters, and he then forms the equation of z equals to c tau, and that then equals to ac all times that thing in the brackets. And he says, but the ray moves relative to the initial point of k when measured in the stationary system with the velocity c minus v, so that x prime divided by c minus v equals t. If we insert this value of t in the equation for z, we obtain that z is equal to a times c squared divided by c squared minus v squared, then that's all times x prime. And so he carries on with his mathematics and he forms these equations. I'll give you a few minutes to look at it. What you're doing is you're transforming between inertial frames. Some people are making a measurement using one inertial frames, and another person is using measurements with another inertial frame. So you're comparing what one person measures with what the other person measures. But in terms of math, you're just getting all this maths manipulation going on. So he then forms this equation where you got another Greek letter, beta is equal to 1 divided by the square root of 1 minus v squared over c squared, and that's the usual sort of like relativistic factor. And he's carrying on. He says phi is an as yet unknown function of v if no assumption will ever be made as to the initial position of the moving system and as to the 0 point of tau, and additive constant is to be placed on the right side of each of these equations. Then further on he concludes the following. This is quoting Einstein. It follows from this relation and the one previously found that this function phi is equal to 1. So it was a lot of mathematical manipulation to get to deciding that phi is equal to 1. And so for the equations using phi in it, with the tau and the z and so forth, those equations can be simplified. You could just substitute phi is equal to 1 into those equations, and then they get simplified to what become tau is equal to beta, and that's all times t minus v x divided by c squared, and z is equal to beta all times x minus vt, so forth and so forth. So those are the equations connecting the inertial frames. So repeating these equations which Einstein has for connecting these inertial frames, he has those equations followed by the equation for what beta is, and then he also has an equation where z is equal to c times tau. Now, given all these equations, we want to see whether they are consistent with each other, and as an example, Stephen chooses the values t equals 0, v equals 0 and x equals 1 into them to see if they work. So the relevant equations are the equation for tau and the equation for z and the beta equation and the last equation, z is equal to c tau. So 1, 2, 3, 4. So really only looking at these 4 equations. So v into the beta equation, it gives beta is equal to 1 divided by the square root of 1 minus 0 divided by c squared, and that all equals 1. So really you're just substituting v equals 0 into that equation and you're just left with 1. So this is why the values were chosen, because they're nice, easy, the equations are nice easy solutions for those values. If we now substitute that into the equations for tau and z, those equations are just using beta equals to 1, and so that simplifies them as tau is equal to t minus vx divided by c squared, and z is equal to x minus vt. So the equations have been quite simplified quite easily by choosing a nice simple value for v, namely of v was equal to 0. So substituting t equals 0, v equals 0 and x equals 1 into those equations for tau and z, it gives tau is equal to 0 and z is equal to 1. And then finally we have to check this with the equation of z is equal to c tau. And so for the value of tau is equal to 0, that gives z is equal to 0. So if you note, we've already established that z is equal to 1 from the previous equation, but now using tau is equal to 0, we get z is equal to 0. So Using the values t equals 0, v equals 0 and x equals 0, that gives us two values for z. Z is equal to 0 and 1. So that's another way of saying 1 equals 0. If we try for other values of t, v and x into these equations, well, we get other nonsense. So the equations given by Einstein are thus not consistent with each other, or we are concluding that Einstein is telling us that 1 equals 0. So you've got the choice of deciding there's something wrong with those equations because they're not consistent with each other, or you're accepting those equations and then you're concluding that 1 equals 0. And concluding 1 equals 0 is nonsense. It's a mistake to do that. But that's what Einstein has done with his maths. He's given us some equations, and those equations are supposed to be consistent with each other, and they lead us to saying 1 equals 0. Now, Stephen next goes into detail in his full talk about why he thinks the establishment, which is the physics establishment, have missed this math mistake. But from my point of view, the establishment just ignores Einstein's mistakes. There have been various people, such as this person, Professor Ohanian, and he's written a book on it, and he's studied relativity in a lot, and he has pointed out some of Einstein's mistakes. Those mistakes by Einstein include mistakes in the maths. So Stephen has spotted another math mistake by Einstein. You can't really have 1 as equal to 0, which Einstein's equations give you in Einstein's paper. So what does the establishment do with things like that? Well, it just ignores it and carries on with proclaiming Einstein as a genius. As for experiments, well, the math is just being messed up to fit with experiments, same as the math is messed up in Einstein's papers. And that's the state of physics. It's just a mess in the maths. Einstein's papers, there's a mess in the maths. The physics establishment, well, they just ignore that, and they still say Einstein's a genius. And as I pointed out in previous talks, the physics establishment just keeps sweeping certain things under the carpet. Einstein makes all these terrible mistakes, and the establishment doesn't care, just going to ignore it. Thank you. That's the end of this talk. Thank you. Bye.